not exactly one pronoun along with at least one verb. So if we find the first sentence to be an ideal sentence, let's say that sentence has one verb and one noun, then it is an ideal sentence. So at the end, A should be one and C should be one. Now, if I don't reinitialize, then the next sentence I pick, if that is also an ideal sentence with one noun and one verb, at that point, A will be 2 and C will be 2, which is fine. Because ideally, it should be the condition should be C greater than equal to 1, right? So C can be 2, but A can it be 2? If A is 2, then will the condition satisfy?
No, ma'am.
So even if it is an ideal sentence, this would still fail the condition. That's why before picking every word of the next sentence, okay, once you've come to the end of a sentence, you must reinitialize all the variables. Clear?
Yes, ma'am.
Any other doubts from 5, 6, any week?
Here elements inside the F list are basically it's a list within a list and contain the ideal sentence as its element.
Yeah, S list will contain what it is a list within a list, right? So it will contain all the W lists, and W list is containing all the words of a perfect sentence.
Yes, ma'am. And it will make it a list and append it to the S list.
Correct. That's why the
Okay.
W list is also reinitialized.
Yes,
Because
Ma'am,
ma'am.
after every sentence, you must discard it. Yeah.
Okay.
ma'am, this line number 20 is error, ma'am. That I am asking why it is error there, ma'am.
Because even if you don't reinitialize C, okay, even if you don't reinitialize C, then also it should be correct. If I don't reinitialize C, but what is our condition that it should have at least one verb, right? That means more than one verb can be present also. That is one thing. Basically, this entire thing is error. Since this if condition is wrong itself, the C should be greater than equal to 1.
Ma'am, that both
Misplaced,
lines should come outside the inner is. Then that will be correct.
also it is saying misplaced reinitialization. So if I reinitialize it here, this should ideally be reinitialized outside of this if.
Ma'am,
Yeah,
that
this
I got, ma'am. Line number 20 should be initialized after that if braces, ma'am.
hmm
But if we would initialize here, then what will be the output, ma'am, result?
if you initialize here, okay. See, if the first sentence, let's say if it contains one noun and one verb, so A and C should be one one. Okay. So if I initialize here, then next sentence when it comes, if it is an ideal sentence, then this is getting initialized, reinitialized here. If it is not, then this if won't work. Then if the next sentence
Ma'am,
also
can you
contains,
explain my example, ma'am?
yeah, okay, I'll give an example. Better we write it in a doc. Can you see?
Yes, ma'am.
Now let's take an example. Let's say the first of all, let's change this. Okay, this is correct, greater than equal. Then the rest of the code, in the answer, which lines are having error except for 20? Any other line has error except for 20 and 17?
Line number 17, line number, wait, ma'am.
17 and 20, nothing else, right?
Yes, ma'am.
Now let's say the first sentence that we pick has one noun and one verb. So it fits the criteria. So A, B, C is initially zero, count is S list, W list, whatever. First card we read. Then the word that we are reading, that is inserted into this W list. Now, if part of speech is noun, so let's say the first word that I picked has the only noun that is present in the sentence. So A is now 1. Now this sentence has no pronoun, so B remains 0. Now it has one verb exactly. C is 1. Now we are considering that this condition is correctly given. The line 17 is correct. So if word ends with a full, this is the first word we have picked, right? So obviously this will not end with a full stop. So after I have gone through all the words in this sentence, after I have reached the last word, okay, at this point only this if will be true, right? So after that, A plus B is equal to 1. This condition is satisfied. A plus B is 1 plus 0 here. So A plus B is 1. And we are considering that C is greater than equal to 1. Anyways, this will satisfy since C is just 1. Both these satisfy. Now I come inside this nested if. Count is incremented to 1. That means one perfect sentence we have got. S list is appended with whatever is in W list. That is all the words from that sentence. Now reinitializing A, B, and C as 0 here. Now again, A, B, C are all. If I do it here, so if I reinitialize it here and then W list is also. After this, next iteration. So this is the nested if is ending here and this outer if is ending here and this is the end of the while. After this, I move table 2 and pick the next card. Next card will be the first word of another sentence, right? At this point, count is 1 and A, B, C are all 0. So if A, B, C all are 0, then read the first row again, pick the next card. Now, if the next card, like for example, this one has a noun, a pronoun, and a verb, then first, if part of speech is noun, so let's say the first word is a noun, then A will be again 1. Next word, let's say part of speech is a pronoun. The next word that we pick is the pronoun in the sentence, then B will also be 1. And the third word, let's say it has only 3 words, the sentence. Third word is a verb. E is also. Now, if that is the last word that we picked, then this is the end of the sentence. And again, this condition is true. So again, count is now, is this condition going to be true at this? A and B are
No,
both.
ma'am.
So we won't get into this. Okay. But at this point, A is 1, B is 1, and C is also 1. But if I don't get to reinitialize here, then the next sentence, even if it is a perfect sentence, okay,
Got it.
then it won't be starting from 0 again. So this condition will remain false. Yeah.
And also, ma'am,
Whereas,
the W list should be made empty
right,
for.
W list should be also empty.
Because
So
A, B, and C is still 0 at the end of the execution. So the W list will be empty.
A, B, and C should be reinitialized after every
Hmm.
sentence ends, and W list should also be made empty. Right.
Yes, ma'am.
But this should not happen here. It should happen where? That means
After line 22.
regardless of whether you get a perfect sentence or not, these two should be reinitialized outside of this if, right? That is
Inner if.
Yes,
outside of this line 22. Line 22 ends, here you should do the reinitialization. That is, but once you reach full stop, whether it is a perfect sentence or not, it will always get reinitialized. Yeah.
Yes, ma'am.
Yeah.
Any other? Or should we start week
Graded assignment part, ma'am, week 5.
Ma'am, graded assignment, question number 3.
week 5 or 6?
Week 6 deadline is not over, ma'am. Week 5.
Not over.
Week 5, graded assignment, question number 3.
This is saying that n is a list of 50, first 50 positive inputs that contains one the form of a list. So what will be the value of count at the end of execution of what is this? First line 1 count is initialized to 0. A is some list n. Some list is what? It is a procedure and n is passed as an argument. And B is again this sum list procedure is called with rest of n. That means rest of n means what is removed?
First element.
First element. Right.
1 is removed.
One is removed for the first iteration. Then for each y in A, that means we are picking elements from y. Okay, let's type. Okay, can you see?
Yes, ma'am, we are able to
Okay.
see this.
N list content one be like this initially. So A is having this sum list procedure with this list as the argument. B is having again sum list procedure with just this argument. Yep, for the first iteration. Now for each y in A, so what is the first y? 1. And for each z in B, what is the z? First z is, so if 1 is equal to 2, then count is incremented. Okay.
But it will not satisfy the condition.
So it will
1
not
doesn't.
satisfy the condition. It will actually never satisfy if you keep on doing. But this is only done once. Or is it takers?
Ma'am, first we will go to the procedure, right? And check
Yeah, no,
what
no.
value
I'm
it
just
returns.
yeah, definitely. But I'm just here some list out the file length. So once we call this process, right, in line, we are going to head to line 11. This X is N basically. Out list is a new list which has an empty. New list is X, that means N. So while length of new list is greater than 50, so initially length of new list is 50, right? Greater than 0. So out list is appended with first of new list. So out list has 1, right? And new list is what? Rest of new list. What is rest of new list?
1 and 2 are removed.
Right? 1 and 2 are removed. So everything from 3 to 50. This is the new list. Then after this is done, you again go back to line 3, control 2. Sum list rest of n. Rest of n means this has this one. 3 to 50 is the new list, right? So n is still same. Did anything change in n list?
Ma'am, there is while loop inside the procedure.
Okay, so this will go through all of this, so will take a lot of time to write. Okay, what is happening here? See, as long as as long as it has even one element in it, so this procedure will be repeated. So this is the first iteration. Outlist and new list will look like this. Second iteration, again, as long as the length remains greater than 0, right? So all of the outlist will be updated like this, one after another. So at the end of execution of while loop, outlist will contain what?
Odd number.
So if I every time for I enter this while loop, every iteration outlist first contained 1 and then new list became 3 to 50. Next time outlist length is what? 48 because we removed two element. Now outlist is first of new list, that is 3, and new list is from 5 to 50. Right, third iteration outlist will be
135.
135 and new list is 7 to 50. Right, so at the end of this while loop, outlist is going to contain all the odd numbers, and at one point new list will be what at the end? So
Empty.
let's say 49. Okay, 49 is the last odd number that we have. So if you do rest of that, if I remove the first element, then new list will be empty. This procedure returns what? Outlist. So it will return a list of all odd elements from 1 to 50, right? This is returned. This one is going to be stored in A, so A is going to contain 1, 5, up to 49, correct? Then B, it is saying some list rest of n. So if I start from 2 and do the exact same procedure, B will contain what? All the
Even number.
even numbers, 4, 6, 8, 2, 3, for each y in A and for each z in B. Now after these two lists are formed, then we are going to come to line 4, line 5, do all this for each list. First is this, second is this. So at the end, will there ever come a point where there is an intersection between A and B lists?
No, ma'am.
Alright, so if z equals to y, this condition will ever be satisfied
No.
because these are strictly odd and even domains. So count will never be incremented, right? So at the end of execution, count remains 0. Any other question from graded?
Excuse me, ma'am. Can you please once again repeat why B will be equal to the list of all even numbers?
Yes, this same procedure we are doing, but we are starting by what is passed as argument? Rest of n. So n is 1 to 50, right?
Okay,
So if I do rest
yes,
of n,
ma'am.
it will start from.
Yes, got it.
So just do one skip extra. Yeah, what
Yes.
other from graded? Week 5,
Question of
Then also it is 2, 3, 4, 5, 6, everything, right?
number 10. 9 and 10 are part questions. Now this is the remainder. So A and B are positive integers. Remainder A comma B returns remainder if A is divided by B. J is true, flag is true, and you can pass the do something, whatever you pass as the argument, whatever in. If X is 1, then it will return false. And while J is less than X, that means X is at least what? 3, right? Only then this condition will be satisfied.
Ma'am, actually your screen is not visible to us. The question that you are reading.
Now you can see.
Yes, ma'am. Now we can see.
So this x that we're passing as argument can be any integer. Now j is 2 and flag is true. So if x is 1, if we pass 1, then it will return false and procedure will end right here. But if it is not 1, so j can be anything other than 1, and then we will check line 6 and onward. So if j is less than x, so if j is initialized to 2, that means x has to be at least 3 for this condition to, right? So if I pass x as 3, if remainder x comma j is equal to 0, that means whatever I passed, if it is an even integer, then it will always give remainder 0, correct? If x is even, then it will always be divided by j, that is 2, right?
Yes, ma'am.
So if that is true, that is x is an even integer, this will be true, this remainder procedure will be true, then flag will be set to false and we'll have exit loop. What does exit loop statement do?
Means after that we will not move forward.
Right. So we will get out of the while loop and we'll continue with the rest of the program, which has nothing, so we'll just return false. Okay. So if it is if it is an odd number that we passed, okay, let's say I passed 35 as x. So 35 is less than, obviously 2 is less than 35, so while loop will run. Now what is the remainder of x comma j? 35 divided by 2 will give 1 remainder. So this if condition is not satisfying, right? Therefore, we will not set flag to false. So we are not exiting the loop because we cannot get into this line 8 and line 9. So you will increment j by 1. So now j is what? 3. Okay. So j is 3. Next iteration, check 3 is less than 35. So again, check this. What is the remainder of 35 comma 3? 35 comma 3 is what? That is also not satisfying. When will this satisfy? When j is 5. Correct. 5 completely divides 35. Is this clear?
But ma'am,
Yes.
remainder will not be 0, right? 5
5 completely
7s are
divides
30.
35. So remainder will be 0, no?
Yes, ma'am. Okay, ma'am. Okay, ma'am.
So if the remainder is 0, then flag is set to false and exit loop. So basically what we can see is that this procedure will return 0. Okay. For every number which is not a prime, this remainder procedure at some point it will return 0, right? For every integer which is not a prime. Now if I pass 17, okay, if I pass 17, then will anything less than 17 ever divide 17?
Ma'am,
Yeah.
as soon as it's divided by 5, flag will be set to false and it will exit the loop.
Yes.
Okay,
As
ma'am.
soon as this remainder procedure returns 0, then this condition becomes true. But for prime integer, for any prime integer like 17, will this remainder procedure ever return 0?
No, ma'am.
Nothing can divide prime except 1 and itself, right? So if j is starting from 2, so there is no chance of that happening, that 1 divides 17. And j has to be strictly less than 17 itself. For prime integers, this procedure at the end also, its flag will remain true because it will never enter this line 8. Okay. So this is the crux basically. This procedure will return true only for primes, for all others it will. So question 9 is asking procedure would do something returns true when x is a prime number, correct? And 10 is consider the procedure discussed above. What will be the value of m at the end of execution of? Now this pseudocode does what? L is a list of integers that is given. M is an empty list. Position is a variable set 1. For each element in L, if do something position and do something element, and do something is this procedure. So let's take the first element in L, that is 6. Okay. Now in this if statement, you have to first do something position, that is you have to pass 6. Okay. So if I pass 6 in do something procedure, what will flag return? True or false?
It
6
will
is what?
it will return
False.
the odd positions.
False. False.
So I'm not telling you what the answer is, and let's go step by step. So for 6, this procedure will return false, right? Since 6 is not a prime number. And do something element. Okay. So do something element will return definitely for 6 it will return false, and position is 1. So if we pass 1, then x
False.
equal to 1, it will also return false. So false and false. So if both are false, that means m will. Others, please mute yourself. Position 1, then this is false, both are false. So m will not be appended with the element 6. And then you increment position by 1 more. Okay, so the position now is 2. And for each element in L, so next element is 10. 10 is also not a prime. Okay. And position is 2. So for 2, what will happen if we pass 2 in this procedure?
True.
So 2 is, first of all, this condition is wrong. Line 3 is not equal to 1. Then we come here. So 2 is less than 2. So this is also not going to work, right? So for 2, what is this procedure returning? True. Okay. So if it returns true here, and position is also 2. Element is what? Element is 10. For 10, what will it return? False. True and false will again give false. So will I append 10?
No, ma'am.
So again increment position. Now position is 3 and element is 11. For position 3, that will return what? The procedure will return true.
True.
Right? Since 3 is a prime. And do something element. This. So now element is 11. It is also a prime. So both are true. So 11 will be appended to the list. Okay. Next position is 4. So for 4, again, we know we don't even have to check the elements. So for 4, it will return false. Obviously, 4 is not appended. So for 7, now position is 5. 5 is prime and 7 is also prime. 7 will be appended. So 11, 7 in M list. Next position is what? 6. 6 is again non-prime, so it will be false. What is M list containing at the end? 11 and 7. Here. Whoever asked this question, is it clear to you? Am I not audible?
I have a doubt in activity question.
Okay, which week?
6.3, question number 2.
This one.
Question 2, question 2. Yes,
What
yes.
will be the value of L at the end of execution? Sorted list in. So L list contains 1, 2, 3, 4, 5. Okay. So if sorted list insert procedure does what? Whatever
Actually,
element.
I do not understand the pseudocode above the question 2. This pseudocode.
This is the sorted list insert procedure. So when we learned sorting, insertion, sort, what was sorted list insert doing? That means if I pass a list and an element that I want to enter into the list, that element will be inserted at its correct place, right?
Ascending order or descending order, it means.
Yes. It will always be in its correct sorted position. Now, this procedure, still let's go through it. New list is an empty list, inserted is false. So for each z in L, if not inserted is true and x is less than z. Then new list. So do you want me to take an example?
Yes, ma'am, yes.
Is this the same procedure in the slides or is this different somehow? I think it's the same.
Same, ma'am.
Same, no? This will just do the sorted list. So can you see?
Yes, ma'am.
Yes, ma'am.
See, this procedure does what? If I say have this 1, 2, 3, my list L. Now in this list L, if I want to insert some element X, which is 6. So X is 6 and L is this list. These are the arguments I'm passing. New list is an empty list. Inserted is a variable set to false. For each Z in L, what is the first Z? 1. If not inserted is true. Not inserted will be true when inserted is false. So for first iteration, this part is true, right? Since inserted is false. And X is less than Z. That is what we are checking. So is 6 less than 1?
No.
So will I enter this?
No, ma'am.
No, ma'am.
To get to this part, the new list will be appended with Z. So new list has now 1. Now again you have to check wait, this for each block sending here. So next for each iteration, for each Z in L, what is the next Z?
2.
2.
So not inserted will be still true because inserted is still false. And 6 is less than 2, again no. So basically for all the 5 elements in this, will this condition ever be true?
No, ma'am.
No, ma'am.
No, right?
No,
As long
ma'am.
as X is 6. So after every iteration, the new list will be added with the current Z. So at the end of execution of this, for each block, new list will contain 1, 2, 3, 4, 5, all the elements, right? Then since this is over, now you come to this line, if not inserted is still true. Since this never entered this line, right? So inserted is still false. Not inserted true, so you append X at the end. That means 6 is coming at its correct position. Now this was a very easy example. Let's say we have one example where uh, this list is,
Ma'am, we have to assume the value of x in every condition.
I'm just using this to, make you understand the pseudocode.
Hmm.
X has to be something, right? You are trying to insert something into a list in its correct position. So if this is the list given to you, it's a 2589, you want to insert 7. If you want to insert 7, then first Z is 2. Again, this condition will be false, first iteration, right? Next Z is 5. This condition will be false. So at this point, new list contains what? 2 and 5 because of this line, right? Now next iteration, inserted is still false, not inserted is true. X is 7. What is the current Z? 8. So 7 less than 8. This is true. So now new list will be appended with 7. So new list becomes 2, 5, 7. And inserted becomes true. Okay. So once inserted becomes true, then will this condition ever be satisfied again? Not inserted?
No, ma'am.
No, right? So for the rest of the elements, we just have to go through this line. New list equals to new list plus plus Z. So after this 2, 5, 7, 8 and 9 will be appended. So however, whichever list you passed, whichever element you want to insert in that list, it will always be inserted in its sorted position, right? And this procedure will return the new list, that is with the new element in its correct position. Procedure is clear. So,
Yes, ma'am.
Ma'am, activity 6.5, it has some confirm and refute. I just want to have a little bit of understanding, ma'am, how to proceed about that one.
yeah, I'll. So this question is saying that this is the list I'm passing of 1, 2, 3, 4, 5. And then I'm calling the sorted list insert procedure. First, I want to insert element 5. So element 5 will be inserted where? In its correct position. If the list has 1, 2, 3, 4, 5, so this 5 will come just after this last 5, right? That is the correct position.
Yes, ma'am.
Similarly, now if I want to insert 4, this will come just after this 3, 2, 1, same. So basically every element twice will come. This list, option 3. Clear?
Okay, ma'am. Okay.
So, ma'am, in case of 1, one should come at last of the list, na? After at the end of the list.
Why will it come at the end? First, where is one sorted position in this list? This is in ascending order. So I want one at the beginning, right, with the other
So
one.
we have to maintain the ascending order. We can't
Yeah,
violate it.
this procedure that we are using, that is why the code is given. This code is going to insert elements in ascending order. Okay, in the sorted position, after you insert, the list should be in ascending order. Now for descending insert also, that also I discussed in the last class. That is just you have to change the condition from greater to less. But this procedure will just insert in ascending.
Ma'am,
Next, which
hello.
one did you say? Activity 5.
Yeah, ma'am. 6.5, there is a problem on confirm and refute here.
Which question?
First one, ma'am. First one.
Proposed hypothesis based on paragraph words dataset. Hypothesis adjectives are followed by nouns. The hypothesis that every adjective is followed by a noun. So let con and ref are the list of sequence number of adjectives which confirm and refute the proposed hypothesis. Variables x and y represent lengths of these two lists. Statement 1 is saying the sum of x plus y will give the total number of adjectives in the data set. And statement 2 is saying that sum of x plus y will give total number of nouns in the given data set. Basically, x is what? X is the number, the length of this con list. Con list is what? Is a list of such adjectives which confirm the hypothesis, that is those adjectives which are followed by nouns, right?
Yes, ma'am.
And y is what? Those adjectives which are not followed by nouns.
Okay,
So
ma'am.
is there an intersection between these two lists? No, right?
Okay.
No intersection. So x plus y will give you all the adjectives, total number of adjectives.
Okay.
Statement 1 is true.
Okay. So how to approach this, ma'am? There is some statement that will confirm a
See,
hypothesis.
the hypothesis is what? That adjectives are followed by nouns.
Okay.
Okay, so in our data set, wherever we find a sentence where there is an adjective followed by a noun, that means that sentence is that adjective is confirming this hypothesis.
Correct.
So it will be in the con list. And wherever there is an adjective which is not followed by a noun, that is refuting this hypothesis. So that will be in the ref list.
Okay. But ma'am,
Excuse me, ma'am.
Yeah.
Ma'am, can we please discuss question number 4 also of this activity?
What percentage confirm the hypothesis that words start with consonant? This one is saying VV stores words which start with vowel and followed by words which start with vowel. Right. PC stores words which start with vowel and okay, this one is clear now. Whoever asked.
yeah,
Number
ma'am.
one.
Actually, I have one more question, so I got an interruption. So, ma'am, this one, right, ma'am? We need to actually know what is this value, no, ma'am, before we conclude. See.
No. There is no need to know what is x and y's value. Just by looking at this question, you can answer it. Since you know that there is no intersection between con and ref list, right?
Okay.
That means there is no adjective which is followed by a noun and not followed by a noun. That is not possible, right? And either one should be true. Either it is followed by a noun or not.
Okay. Oh, okay, ma'am. Because, ma'am, in the example, in the video session, they are talking about the physics mark and max mark. That was easy to understand because they were on the video.
Yeah, because you were seeing the cards and all.
Yeah,
but
ma'am.
here you don't need the data because just by looking at this, you know that con and ref are such lists which do not intersect at any point.
Each other. Okay, fine.
This question is saying VV is stores words which start with vowel followed by words which start with vowel. PC is words which start with vowel and followed by words that start with consonant. Similarly, CV and C. So P is what? Length of VV, which is 5. That means 5 such words are there which are starting with vowel and are also followed by a word that starts with vowel. Right? That means if some word starts with A and then it is followed by another word which starts with A, E, I, O, U, anything, any vowel. So that will come under this BV list, right? So there are 5
Yes.
such words, and then
Ma'am,
QRS.
yes, ma'am. Ma'am, actually, this like the question is clear, but the main doubt that I have is that why not the answer for question number 4 is 100, and why is it 101?
Let me. So it is saying percentage confirm the hypothesis that words start with. What is the total number of words present in the paragraph?
Because, ma'am, when we like add all QRS, so it comes out to be 100, right?
No, ma'am. At the last word, which contains the full stop,
See,
we are not counting this because
yeah,
after that,
exactly. Because
no
the
vowel
last
or
word is
consonant are present.
right. Because for the last word, there this we cannot check. It will not fall under any of these lists because the last word doesn't have any word following it, na. So that one single word will remain separate. So sum of these plus one, that is the last word.
Okay, so the for the last word we are
Yeah, because
adding
that
that.
word won't come under any of these.
Okay,
Ma'am,
got it, ma'am.
can you come to the last activity of week 6?
6.7.
I think last question. I think there should be multiple option correct, but they are saying that only
Train
arrival time. Why not departure time?
data on cards from station. Does it sorted use introduction to train data set? Is it given in the lecture? I think this you have to watch the lecture to on which field it is. Exactly remember what is there in the lecture. Is it given like if you have gone through the lecture, you'll know that are the cards sorted according to which field? Because the
I
trains
have
data
gone
set
through
has
the lectures, but but we know that in the trains data type, hmm, they contains the distance, station, arrival time, departure
Mhm.
time, travel time,
Yes,
all of this.
but it must
So
have been sorted for with arrival time. So I have to check that
Yes,
video to
ma'am. In the lecture it is clearly mentioned.
yeah, if it is sorted according to arrival time, if based on that this is the data set, then this is done. See, actually these data sets, why I'm saying what's the lecture, because of course we can take a random stack of cards, right, and without any order. If they have ordered it in some way, then you have to follow that. This is not a general question, it's related to the lecture. It's whatever is there in the lecture that will be. Okay, any other question from
Ma'am, hello.
yes, you're audible.
Ma'am, I have one question in 6.3.
6 point?
3.
Which one?
In last question.
This.
Ma'am, this question basically is insertion sorting procedure, right? We are passing the empty
Right.
list. So we can
Yes.
directly write the numbers in the ascending order.
Why this? Exactly, you can, right? Because since we have seen that for an empty list,
Procedure.
right? For an empty
Yes, ma'am.
list, as soon as you enter one number, there can only be one sorted place for that number. So 5 comes first. Then when you insert 1, it will come with 5. Then 2 will come between 1 and 5. Like so, you can just sort these numbers in ascending order and these
So
are
that means basically, ma'am, when we have an empty list and we pass any number or any random data through that empty list, it is always arranged in a
yeah. See,
particular order.
for a list that has only one element, it's always a sorted list. If you have one element, it has to be sorted. There is nothing to compare it with. My list only has 5, and it is a sorted order. There is only one position to fill, right?
Yes, ma'am. Then, ma'am, if like element empty list contains like we passed a number 5 through that list, and now the second number which we want to pass is 2. Then,
Then 2 will come before 5 for this procedure. Now, if the procedure is written in such a way that we are sorting the list in descending order, then 2 will come after 5. That depends on the procedure. This procedure is for
yes,
ascending orders. Will be for 1 to 3.
Okay.
Anything else?
Ma'am, the 6.52 that says like the percentage. Can you explain that first question alone, ma'am, so that I can follow this second one? The
This one.
percentage, yes, ma'am.
What percent confirm the hypothesis that words start with consonants are followed by words start with consonants? Right. What percentage of such words are there that follow this hypothesis? So how many words are there which start with consonant and are followed with words that start with consonant? This CC list. There are 60 such words.
3.
Correct, ma'am.
Right. So a total number of word is what? For
100, ma'am.
just for this hypothesis.
80.
Total number of words that start with consonant. How many such words are there?
80, ma'am.
80. So 60 by 80.
Okay.
That
Okay.
percent of consonant words that start with consonant follow this.
Okay, ma'am. Ma'am, and the last question, you said that there is a dot which is added, no, ma'am. But my doubt is, ma'am, that dot is there in end
Which
of every sentence, no, ma'am. So, but why are we adding only one in the last, ma'am? And
see,
if you see the
this
word,
hypothesis that we are checking, this will be checked for, let's say my sentence has 10 words in it. So for every word, I can place it in either VV list or VC list or CV or CC. These are the only four possibilities, right?
yes, ma'am.
But for the last word, can you check it? Like for the
Oh,
10th word.
it is only for a sentence, is it? Okay, ma'am. Okay. I thought it's for a paragraph. Then in that case, it will contain the multiple sentences, so it will be multiple dots.
No, that is different
Okay,
for
okay.
a sentence.
Okay. Got it, ma'am. Thank you.
Anything else from 6?
Ma'am, doubt in 7.4.
7, I haven't started. So let's first
Ma'am,
discuss 7.
week 6 practice assignment.
Question.
Question number 3, ma'am.
So this is the last one I can take now. Which one did you say? 3.
Yes.
This
Ma'am,
one.
ma'am, I have doubt in option.
Okay, let me
The
read the question one.
okay, ma'am.
All two sentences similar if both of them have the same number of words and satisfy the conditions. If ith word in first sentence has same part of speech as ith word in second. Really, all the parts of speech should match. For I is greater than equal to 1, less than equal to L, A list and B list are lists that contain the part of speech of words in that is the particular accent. Okay, but I have one issue here. This ith word in first sentence. First sentence has 4 words, and second sentence has 5 words. Then not right. Will work only for sentence which have same number of words. Yes. So A list and B list contain what? They contain part of speech of words in 2 sentences. Right. So if I have noun, verb, noun in some sentence, then A list for that sentence will be noun, verb, noun. Right. For B list, whatever part of speech that sentence. Procedure is saying is similar. This procedure accepts the 2 lists as parameters and checks for similarity of A and B. So C in the procedure, C list is an empty list, A and B I'm passing as parameter, and first condition it is checking is that the lengths are same. If the lengths are different, then we cannot match, right? If they're uneven.
Yes, ma'am.
So if it is same length, then we will continue to line 6, where C list will be, B list will be copied into C, then we have to put the rest. Which option you have difficulty in?
Ma'am, last option is correct.
Saying for each x in A list, if x not equal to first of C list. If it is not equal, then you can definitely end the procedure there. If it is equal, then again C list will contain rest of C list. That is, remove the first element. That you can again match with the second element in both. Yeah, this. But wait, is this? This is the wrong option. Return should be true. This option is.
Ma'am,
Last.
my doubt is the second bracket, the indentation.
Yeah, indentation is. It should be to the left.
Okay, ma'am.
Yeah, that is a typing error, right? Option is correct.
Okay, ma'am.
Anything else?
Excuse me, ma'am. I sent you a question in chat section. Please solve that.
Vaishnavi?
Yes, ma'am, I have sent a question.
I'm not able to.
In chat section, I have sent. Should I send it again?
No, no, I got.
Should I?
Tired. This one, right? Some visible.
Yes, ma'am.
Yes, ma'am.
So Z is a row in the table with the following data. Z sequence number is 12, pages is 350. What will be the contents of the list some books at the end of execution of this code? Okay, so some books initially contains all this information, and what is these two lines? Insert Z some book. Okay, so we want to insert this, and initially some books has this. This is the procedure. So procedure insert. So we want to insert Z, which has sequence number 12 and pages 350, right? S books is an empty list. Inserted is initially false. So this is again what? Basically, it is the insertion.
Ma'am, I have a doubt in option. Why second option is correct?
You think second should not be correct. So X is Z with number 12 pages and book. S books empty, inserted false for each Y in. What is the first Y? In books 5, 220. Right, this entire thing will come. So if X dot pages is less than equal to last of Y, what is last of Y? 20. 350 less than 220. So you will not enter this if. Instead, in S book, you will append whatever is in Y. So at this point, S book contain what? 5, 2. Right? Now next iteration, what is the next Y? 10, 350. So is 350 less than 350? There is a less than equal to. So 350 is less than equal to 350 and not inserted is what? True, because inserted is false still. So after this, what will come? If both these conditions are true, then I'm going to append it to S book, right? So after this 12, 350 will come. Why do you think this should not be true? Is
I
clear now?
thought, yes, I thought we have to keep it in ascending order. 10 should become before 12.
No. See, it depends on what condition we are checking. Since here we are checking with the last of Y, right? We are only checking with the page number. We are not checking the sequence number anywhere, na? So once it satisfies this condition, at that point you have to insert because you are entering this loop. Okay, this if block you are entering. So at that point you have to insert the new Z since it is satisfying both conditions. Yes.
Yes, ma'am. Yes.
Now, should we start week 7? All your doubts, sir.
Yes, ma'am, you can start because the time is very short. The deadline is
Just,
15th.
okay, it won't take long. Cover everything. Just give me 2 minutes, okay? I'll be. All right, let's start. 7. So, week 7 is about dictionary. Is my screen visible?
Yes, ma'am.
So, before we start, let me tell you, we have done list till now, right? List is one type of data container. Dictionary is also another type. So, dictionary contains key value pairs. That means there is key, and respect to that there is a value 1. Now, dictionaries will have many such key value pairs as key 1, key 2, value 1, value like this. But the key point here is that all keys must be unique. No duplication in the key value. But in the actual values, they can be anything. So they can be duplicates, unique, whatever. So this is a basic concept. Now there will be also dictionaries within dictionaries, nested dictionaries, that is, just like list is within list. So a list keeps a sequence of values. We can iterate through a list, but in a list, can I randomly access a position? No, right? We always have to go that for each block and traverse the entire list. Now, this is the good thing about dictionaries is that random access is possible. If you know the key, you can get the value. So, dictionary stores key value pairs. For instance, chemistry marks value for each student, but student ID can be the key and chemistry mark can be the value. So, two students might have scored the same chemistry mark, but their IDs will be different, right? They will always be unique. Just like a train route can be the key and the station can be the value. Train route will be unique, but source station, more than one station trains can start from the same station. So like this. Present the key to extract the value takes that same time for all keys. That means random access is possible. So whichever key you want to access, it will take the exact same time. Okay. So M is equal to chem marks, where if we say chem marks Rahul. If chem marks is our dictionary and Rahul is the key. So this will fetch what? Chemistry marks of Rahul, which is the value stored against this key, against source station 10215. So it will give you what? Source station value, that is where this train is coming from. So this is the key 10215. So whenever you want to fetch the value for a particular key, this is syntax. Write the dictionary name and then within third brackets you have to write the key within quote. Okay. So let's just so at a raw level, sequence of key value pairs within braces. For list, third bracket was this called. For dictionary, it is braces. No, this is an empty dictionary. So within dictionary, we store values like this: keys to value, keys to value. See, all keys are unique. Values can be anything. This is empty dictionary. How can we access a value? By writing the dictionary name, then within third brackets write the key inside quote. Assigning a value, how can you assign a value? If I want to insert a new key value pair, let's say I want to insert some student AB with marks 92 in chemistry. So I will write chem mark and ABC 90. This created a new key value pair which inside the dictionary will look like ABC is to 90. Dictionary must exist to create new entry. So if I don't have a dictionary to begin with, obviously you cannot enter because the dictionary must have a name, right? So first you have to initialize a dictionary. Like D equals to open and close curly brace. This means an empty dictionary has been initialized under the name D. So this is one example. We want to collect chemistry marks for all students in a dictionary. Now, always we are going to choose such a field as our key, which is unique. Like we can choose the student ID or student roll number. These are unique fields. We can choose the key values as these. Like chem marks is first initialized as an empty dictionary. While table 1 has more rows, so you're now picking cards from the course data set, right? Pick first card X. Name equals to X dot name, whatever name is present. So here we are considering that students have unique names, right? All students have unique names. If we consider that, then only this will work. Yeah. Asking something? So name is first equals to X dot name and marks is equal to whatever that person whose card you picked, whatever marks he has scored in chemistry, so X dot chemistry mark. Then you can write like this: chem marks name will be assigned the value marks. So here name is this X dot name which becomes the key and chemistry marks of that person becomes the value. Like this, you can do this key value pair for the entire scores data set by doing this while loop, right? This is clear for everyone, how to create a dictionary? Yes, no?
Yes,
Yes, ma'am.
So how do we iterate through a dictionary? Like for your list, how did we iterate through a list using what?
For loop.
For each, right? For each block.
Yes.
Basically a for loop. So how do we iterate through a dictionary? First, we will iterate using the keys of the dictionary. So if I call keys of D, keys of D is a function or a procedure which will return a list of keys of that dictionary. Like if for that chem marks dictionary, if I wrote keys of chem marks, so this will return what? A list of names of all students, which are the keys of that dictionary. Keys D is the list of keys of D for each K in keys. So there is some procedure which gives us this. Okay, we are not discussing that. Example, compute average marks in chemistry. Now, if I want to compute average marks in chemistry using this chem marks dictionary that I created, so average means I need a sum and a count, right? So instead of sum, we are using the word total. Total and count are two variables which are set to 0. Now, for each K in keys of chem marks, whenever you say keys of chem marks, this returns what? List or dictionary?
List.
List, right? List of keys of chem marks. K1, K2, like this, there will be a list. What are the keys of this chem marks dictionary? What are the
And
keys?
name of that
Names
student.
of students, right? Yes. So names of all students will be present in this. Now, for each such student, total will be incremented by, that means we will add the sum of chemistry marks of all students here, right? Whenever we write chem marks K, that means chem marks for this student, this key. For each K, that means let's say the first student, so his name will come here. Whatever marks he has put will be the value associated to. So total at the end of execution of this for each block, total will contain sum of chemistry marks of all students, right? And count will contain number of students. Once this is done, then you just write chem average equals to total by count. This is the average calculation. Okay, this is how we process dictionary. Now, how can you check whether a key is already present or not? Because if a key is already present, then you cannot duplicate it, right? So typical use of dictionary is to accumulate value. Accumulate means just gather value. So runs, if runs is a dictionary and Kohli is a key, this this key for this dictionary will be storing what? The value of runs by Virat Kohli. Now process a dataset with runs from different matches. So each time we see an entry for Kohli, we are going to update its score. Am I going to create a new entry for Kohli in the dictionary, or am I going to just add this? Every time we see an entry for Kohli in our data set, in this runs dictionary, am I going to create a new entry for Kohli?
No, ma'am.
No, right? Because Kohli has to be a unique, so we'll just increment his score. Okay, that's why runs Kohli plus whatever is the score in that card. So what about the first score of Kohli? Create a new key and assign the. So the first time that you encounter that, okay, Virat Kohli's run is this. This is the first time you have encountered Virat Kohli's name. Okay, and you create one entry, runs Kohli score. After that, whenever you encounter Kohli again, you are just going to update the score, not a new entry.
Excuse me, ma'am. But ma'am, what if we want to create a list, like a dictionary, where like I want to enter the runs scored by Kohli in different matches separately. That is, maybe in match one he scored uh, so and so, then in second.
Then you have to create such keys where the keys are still unique. Then you cannot use his name as the key. Okay, some other field you have to work with.
Okay, okay, ma'am.
Maybe the match number would be the key.
Okay, so in that match number, different values will be assigned accordingly.
Yeah, like if you see, this can be done using a dictionary within a dictionary, where Kohli can be the outer key. Okay, the outer dictionary key. Like we can have it like this. So this is the outer dictionary. Inside this, I have one key Kohli. Now for Kohli, the value is also a dictionary. Now within this, you have match number 1 and his run, then match number 2 and his run. This is separate key value pair. Okay, this way you can store it. Clear?
Yes, ma'am. Now clear. Thank you.
Yeah.
Ma'am,
Hmm.
ma'am, this runs Kohli is fetching the value
Yes,
of
runs
that
Kohli is
key.
fetching the value of the correct.
Okay, ma'am.
But ma'am, sometimes the dictionary can contain key also, only key.
Only key without any values. Then
Yeah,
what is the point? Like what are you trying to fetch? If
because
I
in the
need only keys, then I can store it in a list also.
because in some question in the 7.3 they are giving that kind of answers, only key.
Then maybe they are extracting the keys from that dictionary. That I want the whatever are the keys in this dictionary I want. So at that point you can call the keys procedure and it can fetch all the keys in that dictionary. Usually dictionary is always a key value pair. But I'll check the question first. So how do we know whether to create a fresh key or update an existing key? The question. So for this I must I must know whether a key is already present in the dictionary or not, right? If it is already present, then no need to create a fresh key. We'll just update the value of the existing key. If it is not present, so we have to check. So basically, we need to check whether this key is a member of this dictionary or not. Okay. So for that, we have one more procedure called isKey. So isKey procedure has two arguments in it. One is the dictionary itself. One is the key that we are searching. Now in that runs dictionary, let's say if I pass runs here instead of D, and for K, I am passing Kohli. Kohli is already a member of this dictionary. It is already a key, right? So this procedure will return true for this. Now let's say for Sachin, I don't have an entry. So for Sachin, this is key procedure will return false. That means there is no such key called Sachin in this dictionary. So I need to create a new one. Two procedures, remember, one is keys of D, right? This will return what? Keys of dictionary D in a list. And one is key of D comma K. Okay, this is returning what? whether K is a
Element inside dictionary D.
don't say element, say key.
A key. Yes, sir.
The entire key value paired is an element. So whether K is a key in dictionary D or not. If it is a key, it will return true. If it is not a key, it will return false. So typical, see, this is how you use it. If is key runs code. That means if this returns true, that means Kohli is a key. Then you are going to update score. Or else it is not true, returns false. That means Kohli is not a key. So you will create a key. Okay, this is key creation syntax. Now,
Ma'am, is it possible to have two values for one key, ma'am? Just like a student which has you can store
wait,
in that.
your voice is very muffled. I cannot properly hear.
Ma'am, now I'm audible, ma'am.
You are audible, but I can't clearly listen. Okay, you try saying.
What I'm asking is it possible to have two values in a value? Just for example, if I have a student, I have to store chemistry marks
I
and maths
still can't
marks.
hear anything. Can anyone else hear what he's saying?
No, ma'am.
Who is this? Okay. Can you please write your query in the chat box?
His voice is not clear.
Yeah,
What
your
I'm
voice is
saying
not
is,
clear.
if I have a student,
Tell him to speak Hindi, ma'am.
We cannot
hello?
hear actually. Can you write it down, your query? Okay, just write it in the chat box. Till then, let's discuss this one thing. Is key procedure. Okay. Once I've written your query, you let me know. Okay. So implementing is keys. Now, how do I implement this procedure? That will check whether a key K is already present in dictionary D or not. So first we'll have found as a variable which is set to the value false. Now for each key in keys of D, that means keys of D returns what? List of keys, right? So within
Yes,
that
sir.
list, now we are going to traverse. We are going to check with every key. So for every key, we have to compare it with K. If anywhere I find a match, then found will be set to true and I will exit the loop and I will return the value of found. That means true. Now, if K is not a key in this dictionary D, then this match will not be found, right? So found will not be set to true and I will return false, which was initial value. Clear? So if it is a key, we will return true. If it is not a key, we will return false. Is key procedure okay for everyone, right?
Yes, ma'am.
Yes, ma'am.
What else? Yeah, so this is just a summary. So dictionary is sequence is like this: key value pairs, random access is possible, and getting any key value will always take constant time because you can randomly access using any key. For any key, it will always take the same time. So if it is a constant time, it is order of 1. Okay, this is O1 time. Now, usually create and we start using dictionaries by creating an empty dictionary first, then you can insert key value pairs like this. This is how you insert new keys, right? And then you can update. If I want to update key K1, then I'll write D K1 is equal to D K1 plus whatever field is there, maybe score. So whatever cards score you want to add to this, you add it. Okay, this is update. And these two things. So iterate through a dictionary using keys of D. Keys of D returns a list. And using the list, we can iterate through all the keys in that dictionary. And is key will return true if K is a key in dictionary D already. If it is not present, then it will return false and you can create a key for K. Okay. Now let's discuss the next slide. Okay, did you write your key? Okay. If I have a student and marks, your question is, yeah, if I have a student and marks dictionary, then it is possible to have store two value for a single key student. Yeah, you can do that, but then it will be a dictionary within a dictionary. Okay, because one key value pair, it cannot be like this. It can be in this form. If you want to say, for every student, I want to insert both the marks of maths and physics. So one way you can do that is if the dictionary is called, let's say, students dictionary. Okay. So this could look like for student with roll number 1, if I'm taking roll number as the key, because roll number is unique. So for roll number 1, inside this I have one more dictionary in which I have the math mark, where math is key, and physics mark, where physics is key. Okay. Similarly, for roll number 2, you will again have this same dictionary within a dictionary, one for math, one for physics. Okay, I hope this is clear. But for one key, there will be only one value. Okay. It won't be like one maths comma physics, both marks you're writing. This is wrong. Okay, let's do the next slide. Is this visible?
Yes, ma'am.
Like, is the font size okay? Can you read?
Yes,
Yes,
ma'am.
ma'am.
Okay. See, this one, be a little mindful. Okay. We are going to discuss that birthday paradox problem in the context of dictionaries. So this is one example before they have discussed that customers buying food items. So we want to find customers who is buying the highest amount of food items. How we can do that is this procedure. So I want customer who buys highest amount of food items, that is maximum number of food items. So create a dictionary to store food purchases. Customer names will be the key. Okay. Assuming that all customer names are unique. No two customers have same name. Number of food items purchased are the values. Okay, like if customer ABC has purchased 10 food items. So ABC is to 10 is one entry. Then if customer XYZ has purchased 20 items, XYZ is to 20 is another entry. These will be in a dictionary. Okay. So food D is a dictionary. Fine. This is an empty dictionary, first we initialized. Now, this is I think from the shopping bills dataset. So while table 1 has more rows, that means we're going through that dataset. So first card you pick. Whatever is the customer name in that card, you're going to store that in the variable customer. And items. Okay. Items you will store in the variable items, x dot item. That is how many number of items he has purchased. Now for each row in items. So items is what? Items has, it can be a lot of items, right? A person who has bought 10 different items, for them the items will have 10 rows, right? So for each such row in items, you're going to check if the category of the item is from food. It can be any item, right? Stationery, food, clothes, it can be anything. But we are only interested in people who have bought the highest number of food items. So first we have to check the category of the item. So for the first row, I'm checking, let's say this X person whose card I've picked, let's say his name is ABC, and they have bought, let's say, 5 items. So for each row in this item, these 5 items, first row, I'm checking if the category of the item is food. If it is food, then you go to the nested if. Is key food the customer? That means, is this ABC customer already a key of this dictionary? So think of this like this is our first iteration. That means food D dictionary is empty, doesn't have any keys, right? So this is key procedure will return what for first iteration? True or false?
False.
True.
Not true, right? Because ABC is not yet a key of food D dictionary. D is empty dictionary. It doesn't have any keys. So is key will return false for customer name ABC. Since it is false, so we are going to create a new entry for this customer. So food D customer is equal to food D customer plus 1. So now in food D dictionary, we have an entry like this. ABC is to 1. Correct? This is how it looks like now. Now, next iteration when you go, so this nested if closes here. Okay, and this outer, this is the nested else. And this is the outer if, and this is the for each block closing. And this is the while loop closing. So for the next iteration of the for each block, I pick the next item from this list of 5 items. So if that item is also a food, okay. Next when I check is key food the customer, what will this return?
True.
because now I have a key already named ABC. So you're just going to update it. So now he has brought 2 food items. So now ABC will be 2. Next item, if it is not a food, so this condition is not valid. So none of this part matters. We will just move on to the next iteration. So like this, for every customer, you are going to create a key value pair with the customer names is to the value will be the number of food items that he has purchased. So once this food D dictionary is completed, it will look like this. Some ABC has purchased 2 items, XYZ has purchased 5 items. These are all food items, right? And now you want to find who has the highest value, right? So if I have this dictionary from this, can you find out who has the highest value? Can we find out?
Yes, ma'am.
Right, just do the maximum procedure that we know. So check for all the values and compare all the values until you get the maximum one. So it is main thing here is creating the dictionary. After that, anyone can solve. Now this question is going to take a bit of time. So birthday paradox, what did we say? That no matter what is the birthday paradox problem? That no matter how small our data set is, okay, there is still some chance or some probability of 2 people having the same birthday. Right, that is the problem. Even if I have 10 people in my data set, there is still a chance that 2 people out of these 10 might have the same birthday. So how are we going to solve this using dictionary? See. So find birthday shared by more than one student. This is our goal. Let's say some student's birthday is on 5th of February. Okay. So we want to check if any other student's birthday is also on that same day. So what can we do? First, we can create a dictionary with date of birth as keys. So are any 2 dates going to be same? Dates are unique, correct? All dates are unique.
Yes, ma'am.
So they can be used as keys in a dictionary. So we will use date of births as keys and we will record the duplicates in a separate dictionary. So how this is done? See, first we have a dictionary called birthdays and another dictionary we have called duplicates. Both are empty initially. Now you go through the data set. Let's say this is taken from that scores data set only since it has student birthdays recorded in it. So for the first row in table 1, DOB is equal to x dot DOB. That means whatever this person's date of birth is, whose card you just picked, we will store that in the DOB variable. Let's say 5th Feb is the date of birth. If is key birthdays DOB. So this is the first card you picked. That means birthdays was initially empty. So is key will return what?
False.
False.
So I will go to the else part, right? Else part, I will create an entry for that date of birth. So now birthdays dictionary looks like this. So this is the dictionary for 5th Feb. Now I have an entry. So 5th Feb is equal to true. This is the entry. Now let's say we pick the second card. So move this current card to pile 2 and pick the second card. Now second person, let's say, has birthday on 2nd of Jan. So for them, is key will return what?
False.
Again false.
False.
So I have to create another new entry for 2nd Jan. So birthdays looks like this now. Again true. Now if the third card is of a person whose birthday is also on 5th Feb, right? Then is key will return what?
True.
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 Then we will go to the
Duplicate will be wrong.
duplicates dictionary. Yes. So this is a separate dictionary. This is only for those entries where we know that this date of birth is shared by at least 2 students. So then it goes to duplicates dictionary. So duplicates will also have a similar structure only. So 5th of Feb will be an entry here now. 5th of Feb equals to true. That means not equal to, let's write is to. That means 5th of Feb is one such date of birth which is shared by at least 2 students. So it is in duplicate. Okay, like this we will go through the entire data set. So tell me in birthdays, okay, in birthdays dictionary, will I have all the unique date of births of all students? Like if I have 50 students, okay, some of them have duplicate date of birth, that is some of them are born on the same day. Okay, But will I have all the unique date of births as keys in this birthdays dictionary? Yes or no?
Yes,
Yes.
ma'am.
Right. For every new date of birth, we are creating an entry. And duplicates will contain which date of births? Where at least two people are born on the same day. Right? More
Yes,
than
ma'am.
two also is possible. So they will come under duplicates. So obviously, best case scenario is that, I mean, one scenario can be that duplicates dictionary is a smaller dictionary than birthdays. Okay. Usually, obviously, that will be the case. Now, if all people are born on the same day, then only both these will have the same number of entries, right? All students are born on the same date, then birthdays will have one entry, duplicates will have one entry. But other than that, birthdays will generally be a bigger dictionary than duplicates. So now it is saying, if we want to record the names of those who share the same birthday, now we want to record the names and store a list of student IDs against each date of birth. So now this is the goal. So birthdays dictionary is containing all the date of births of unique date of births of people, and duplicates is containing those date of births where more than one person has been born. Okay, so we want to record the names of those who share the same birthday. And we want to store a list of student IDs against each date of birth. Fine. So see what changes we have made in the code. Up to this, everything is same. So we read the first row from X dictionary, and whatever is rate of birth, we are going to store that in DOB variable. Next, in sequence number variable, we are going to store the ID or sequence number of that person. Now, if is key, again, same thing. If DOB is already a key in birthdays, that means already some person has a birthday on that date. So that will be entered in duplicates, right? That means it will be an entry for duplicates dictionary. And in birthdays DOB, we are going to append one more thing, which is sequence number. Okay. So if I append sequence number to that DOB, now how will it look like? So birthdays, this birthdays dictionary, and this is duplicates dictionary. So let's say again for 5th of Feb, we have seen that there is an entry in birthdays, right? 5th of Feb. Against this, will I have a single value or will I have a list?
A list, ma'am.
Look, for every new entry in birthdays, we are assigning the sequence number as the value field in the form of a list. So let's say the first person whose birthday was on 5th Feb was having ID 1. Okay, so initially it was like this. Now we found another person whose birthday is on 5th Feb. So that sequence number of that person also has to be appended. Let's say he has ID 2. So now it will look like this, and duplicates will have also one entry for 5th Feb. Where what is the value? For duplicates, it is
2.
still true. Okay. So now every person, that is against every unique date of birth, we will have the value as the list of IDs of students who are born on that day. Okay. So have we recorded, like, this goal is satisfied, right? We are storing student IDs against each date of birth. Is this code clear for everyone? Any doubt here? Okay. Next, see, it is saying can also store the students associated with each date of birth as a dictionary. Okay. So how can we do that? We need to store students associated with each date of birth as a separate, as a dictionary itself. So birthdays empty, duplicates empty, while table 1 has more rows, pick the first row. Now let's say first person DOB is again, take the same example, 5th Feb. Sequence number, let's say, is 1. So for first iteration, obviously it is an empty dictionary. So we need to create a new entry, right? So is key returns false. So come to the else part. So birthdays DOB. Now this is what? This is a dictionary inside a dictionary. Birthdays was already a dictionary here, right? Now for every separate date of birth, okay, this will have a separate dictionary. That's why we are initializing one more dictionary here. So birthdays will now look like this. This is the birthdays dictionary. Okay. It is a dictionary on its own. Now inside this, I have an entry for 5th Feb, which is also a dictionary. Okay, so against this 5th Feb, the value that is stored is in the form of a dictionary. What are the keys of this inner dictionary? Can anyone tell me? Look at this code. What are the keys of this inner dictionary?
Sequence number.
Sequence number. So if this person has birthday on 5th Feb, right? So it will be 1 is to true. Again, if I find the second person who also has birthday on 5th February, so there will be one more entry here. 2 is to true, like this. Now, if one more person, third card that I pick, let's say that person has birthday on 2nd Jan. So as soon as I write 2nd Jan, I'm also creating a separate entry for the sequence number of that person. Let's say it is 3. So 3 is to true. Now, one second. Yes. Now let's say the fourth card that I pick is also a person who is born on 5th Feb. And his sequence number is, let's say, 4. So is key, birthday's DOB. This is going to return true or false. Is 5th Feb a member of this
True.
birthday's dictionary? True. So duplicates will have one entry, right? Duplicates DOB, true. Birthdays, okay. Birthdays DOB sequence number. This also has to be set to true. So this part is for creating a new entry. This part is for just updating. Okay. That means if I already have that DOB in my birthdays, I don't have to create a new entry. I'll just add a sequence number and say that, okay, this is also true.
But
Fine.
ma'am, why do we like why we want to say true? We have already like in the code that we just did before this, that was also fine. That we were just writing that okay on this particular date, so and so people are have the same or they have the common birthday. Why do we need to write true in front of them?
Because they
Like
are
what
just,
is the
see, what the goal is, they're just asking that can I store the students associated in the form of a dictionary. So earlier we were doing it in the form of I think a list, right? Here we were doing it in the form of
yes
a
ma'am,
list.
in the form of a list?
Yeah, just that, change that to a dictionary instead. So both ways we can do it. That's what it is showing.
So how will we use this second dictionary like that we are creating this?
Duplicates. Which second dictionary? Birthdays or duplicates? These are separate codes, okay? These are different. That code is different. This code is different.
Yes, ma'am. So how will we use this? Like when we are writing that, okay, for this particular sequence number, it's true. So how will we use
So
this?
you can, let's say, if you want to find that, if I say that how many people, okay, what are the sequence numbers of students who are born on 5th Feb? Then you can call that keys procedure, keys 5th Feb. That will return a list of all the sequence numbers.
Right, ma'am.
If I write keys of 5th Feb, okay, then this will return a list of 1, 2. These two people are there inside this dictionary. So this
Yes.
is one usage. So, yeah. So every time there is same date of birth, you are going to obviously create an entry in duplicates. Okay. And if it already has an entry, then you don't have to do anything, because duplicates dictionary, we are not changing anything. Only in birthdays dictionary, we are adding the sequence number field also. So any confusion in this code?
So
Ma'am, I have one doubt. In the case of if function, sometimes true will be coming and sometimes false. What is the logic in that one?
In which?
If function is key, birthdays, one function is
So
there, right?
when is this going to be true? This is going to be true if that date of birth is already a key of birthdays. That means some person already has that date of birth and we have seen his card. Right, and we have made an entry in birthdays dictionary. Now, if you see a second person whose date of birth is same, then is key will return true because that key already exists. Right. If it returns true, then duplicates DOB will be set to false. Sorry, duplicates DOB will be set to true. That means in duplicates dictionary, we are creating an entry for that. Now, tell me one thing. Duplicates dictionary is initially empty. So the first person I see, their date of birth is 5th Feb, fine. I if I try to enter this, so is key birthdays DOB. If is key, if birthdays is initially empty, so we will create an entry for birthdays, right? With this empty dictionary. So the key value pair initially birthdays looks like what? 5th Feb and an empty dictionary, right?
Yes.
Now within this empty dictionary, next line, what is the sequence number? For that you will create an entry. So if the first person, the sequence number is 1, so 1 is to true. Okay. Now if the second card that I pick is also of a person who's born in 5th Feb and his sequence number is 2. So now is key will return true because for 5th Feb there is an entry in birthdays. Okay. So now you create an empty in duplicates. So duplicates dictionary has what key value pair? DOB 5th Feb
Yes.
is to true. Now if the, and you obviously have to append this sequence number. Okay, but one thing, if it is true, that is if the second person is also a part, the second person is also from 5th Feb, then the is key will be true. Duplicates we are creating one entry and birthdays DOB sequence number. So you have to create one entry here also, right? 1, 2, 1 is also true, 2 is also true. Now if the third person that comes is also born on 5th Feb and their sequence number is 3, so then also its key will return true. But will you create a new entry in duplicates? For 5th Feb, do I need a new entry? If the third person whose card I'm picking is also born on 5th February, then in duplicates dictionary, will you create a separate entry for 5th Feb again?
No.
No,
No,
ma'am.
right? It is already present, so nothing to do. That's why just this line is written. Duplicates DOB is equal to true. So this only, nothing else. But for birthdays, you have to add one more sequence number. So birthdays DOB for this 5th Feb dictionary, we are going to add 3 is to true. Okay, this is how this will work. Is this clear?
Tell me, ma'am.
Sorry?
Clear, ma'am. Thank you.
Okay.
Ma'am,
Anyone else? Yeah.
ma'am, one more doubt I have. Ma'am, like for example, when we were creating this separate dictionary for particular dates,
Hmm.
then when we asked for the list of the keys for a particular date, it is
Hmm.
going to return us the value. That is, in this case, it is 1, 2. So,
Hmm.
but what if we were not creating that separate dictionary for the number of people, or that is the sequence number? Then, if we ask for the list of people who were born on the same date, then
So
what will it suggest?
where are you storing the sequence number then? If you are not creating a dictionary, you have to store it somewhere, no? To extract
Ma'am,
that
like in the
data.
last code, we were simply writing that for 5th of February, the
This
sequence
one,
number
right?
list. Yes, ma'am.
Yeah.
Right.
So here, if I ask, if I want to know that who all are born on 5th Feb. Okay, so you can just write, in this case, just write birthdays 5th Feb. This will give you the list that is corresponding value that is stored for this key. That is the list of sequence number 1, 2. You will get this
That
as the
means,
answer.
ma'am, both these codes are like
Yeah,
performing the
same
same.
thing. They're
Yeah.
performing the same thing. One using list, one using dictionary.
Okay, so there's not much difference. It's just the
No,
difference
no.
of a list and a dictionary.
Yes, that
Same
is
thing.
what it is saying. That can I also do this using a dictionary?
Okay, got it. Thank you.
So birthday paradox clear for everyone? Any doubt? Now that you remember that resolving pronouns problem, right? That if I have from the paragraph words data set, if I have a sentence, let's say I have this 2 sentences that mm, Rahul is a boy. He is 12 years old. If these are 2 sentences in order, okay, this is the first sentence, then this is the second sentence that comes in order. So for this he, I need to find out what is the noun for this pronoun, right? That is, which noun is this pronoun referring to? So this was one problem. How did we solve it before? That we just traced back to the last noun, right? Trace
Yes,
back
ma'am.
to the word which was the last noun. But we also saw that this is not a foolproof method. Okay, because if I have a sentence like this, Rahul is a boy. Let's say Mr. Roy is his teacher. So this his, for this he, his. What is the preceding noun? Mr. Roy. But
Mr. Roy.
is this pronoun actually referring to this or Rahul? It is
Rahul.
referring to Rahul. So in that case, this method will not work, right? So resolving pronouns, how we can do this using dictionary. So we are going to create a dictionary with part of speech as keys, sorted list of card numbers as values. Okay. So part of speech will be the key in this dictionary. And value will be what? List of card numbers in sorted order. Okay. How this is happening? See, part of speech is empty dictionary initially. Now, if I write this part of speech noun, what do you understand? That I am creating an entry in part of speech dictionary, correct? Where the key is noun. And against this key, I am assigning an empty list. So whatever values are there, they will be coming in form of a list. Again, I'm creating one more key for this part of speech dictionary, which is pronoun. Against this, I again have a list which will contain all the card sequence numbers. Okay, they will all come in the form of a list. So part of speech dictionary will look like this. There will be one key noun. Against this, one list will be there, and there will be another key pronoun. Against which again one more list. Right? Now table 1 has more rows. Read the first row. So this is from paragraph words dataset. If the part of speech of the first word that we picked is noun, then that will be appended. The serial number of that card will be appended to the nouns list. Let's say serial number is 1. So now nouns, against this noun key, the list contains 1. Okay. If part of speech is pronoun, then append it to pronoun. So next card, if I pick the part of speech is pronoun, then append it here. So like this, at the end of execution, against this noun key, you will have a list of all sequence numbers which have noun words stored in them, correct? And against pronoun, you will have a list of all sequence numbers of cards which have pronoun words in them.
Yes,
Okay. So now I'm going to match. Now I have the lists with me. So iterate through the dictionary to match pronouns. Note that part of speech noun and part of speech pronoun are both sorted in ascending order of serial number. Okay. So the serial numbers that are stored, the cards that are stored, we are assuming that they are in ascending order. Okay. So match D is again one more dictionary. Now for each P in part of speech pronoun, that's the first. What is part of speech pronoun? It is containing what? A list. So if I write part of speech pronoun, it will give me a list of serial numbers in ascending order, which are for pronouns, pronoun words, right? So for each such serial number, matched variable will be initialized to -1. Now for each n in part of speech noun, again one list we will get of all the serial numbers in ascending order for cards which contain nouns. So let's say the first. So will there be any intersection between these two lists, this one and this one?
No, ma'am.
No, right? A card is either having a noun or a pronoun. Okay. So let's say the sequence number of this pronoun. Okay. Let's say it is 5, 9, 11. Okay. These are three sequence numbers sorted in ascending order. So these cards with these sequence numbers have pronouns stored in them. And let's say there is 2, 6, and 10. These sequence numbers again sorted in ascending order. These are sequence numbers of cards which have nouns stored in them. So once I pick, so first P is what? 5. And for each N in part of speech noun, what is the first N? 2. So it's 2 less than 5. Yes. Right. So matched will be, this variable matched was initially -1. Now it will be N. N is 2. Else I will exit the loop. That is, I will go for next iteration in the outer loop. Why this is happening? Because obviously the correct noun for a pronoun should come before it. First we introduce a noun, then we call it, then we refer to the pronoun, right? I say first I have Rahul, then I can use the word he or his or him, right? So obviously the noun should be of a lesser serial number than that of the pronoun. Is this clear?
Yes, ma'am.
Card 2 has the noun. Then only card 5 can have the pronoun. Can it happen that card 2 has the pronoun and card 5 has the noun? I cannot write a sentence that he is a boy, his name is Rahul. Okay. If I write it like this, then this procedure will not work. It will work only when the noun comes before the pronoun. Right? That is not even a correct grammatical sentence. You cannot refer to he without a proper noun. So obviously all the correct nouns should have lesser serial number than their respective pronouns. So if that is the case, that we find the serial number 2 for noun, and for pronoun we find serial number 5. So 2 less than 5, so matched is 2. That means this pronoun P, or having serial number 5, is matched with which noun? In serial number 2. Okay. So like this we will do. Now after this is done, this inner loop is done working. In match D dictionary, we will make an entry for pronoun 5. And for that, we will store the value as 2. That means this pronoun 5 has been matched with the noun 2. So match D dictionary will look like 5 is to 2. Understood? Now multiple pronouns can also map back to the same noun. Correct? I can say Rahul is a boy, he is 12 years old, he goes to school. So both of these he words that came, both of these map back to Rahul, right? So again for pronoun 9, let's say, for pronoun 9 also, this 2 can be the value. So for each pronoun, we are going to check all the nouns till we get, since this is in ascending order, so obviously you will get the lesser ones first. So this is how we will match. Is this procedure clear? Any doubt? Anyone who didn't understand? Everyone understood? Okay.
Ma'am, you referred about the second sentence, right? Our dog it is his teacher or something. Then how it will match?
Yeah, see, if I have this type of a sentence, okay, that Rahul is a boy, I wrote Mr. Roy is his teacher, right? So let's give serial numbers to them. This is 1, 2, 3, 4, 5, 6, 7, 8. So in my pronouns list, this will come, right? 7 will be an entry. And in my nouns list, what are the two entries? 1, comma 2, right? These are the two entries.
Yes.
So for pronoun 7, first I picked 7. Okay, P is 7. Now come into the inner for each block. So for each N in part of speech noun. So first pronoun I'm starting with is 1, right? So for 1, this will say 1 is less than 7. Matched will be 1, right? Now again, next iteration, you will pick 2, which is also less than 7. So again, matched will be set to 2. But is this correct? This 7 is not referring to Mr. Roy, it is referring to Rahul. So again, this method is also not full. Okay. So in some cases, this will work. In other cases, it won't work. But this is the same execution using a dictionary. I mean, this is the best effort you can do using a dictionary.
So, ma'am, we have to check the pronoun is the pronoun refers which one, Mr. Roy or Rahul?
So at the end, since Mr. Roy is also having a lesser sequence number than his, right? His is 7, Mr. Roy is 5. So obviously the last iteration will be the one whose value will be stored. So N will be actually not Rahul, it will be Mr. Roy, that is 5. Okay. The last one, the last N in part of speech noun, that is less than P. That N will be stored. So first 1 is less than 5. So first 1 is stored. Then next iteration of inner loop, 2 is less than 5. So 2 will be finally stored, which is also wrong. Right? Are you understanding? Wait, let me tell you one more time. So these are the sequence numbers we have given. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So what are the nouns here? This and this. So noun list will contain what? Let me rewrite.
1, 5, and 8.
Yes. So noun list will contain 1, 5. Boy is also a noun. Anyway,
Oh, 4 is also a noun.
yeah. So it will contain
1, 4,
1, 4,
uh,
5, and 8.
and
Correct?
8. Okay.
And pronoun list will contain just 7. Right?
Yes, ma'am.
So this 7, it is referring to which noun? So for 7, now go into the inner loop. Matched is set to -1. Every time we are checking for a pronoun, match will be reset to -1. So for each n in part of speech. So what is the first n? 1. So 1 is less than 7. Yes. So matched is set to what? Matched is set to what? 1. 1 is the current n, right?
Yes,
Now
ma'am.
next iteration. Now n has changed to 4. So 4 is also less than 7. So now matched is again updated to 4. This is the new value. Now next iteration 5. 5 is also less than 7. Match is again updated to 5. Next iteration 8. 8 is not less than 7. So match will remain 5. Okay. And then when you go for the next iteration, nothing else is present here. So outer loop again. So I'll pick the next pronoun. But for in our match D, once the inner loop is done, we are going to enter a new entry. So match D now has an entry that is for pronoun P, that is 7. What is the entry? 5. Right. But is 7 referring to 5?
No,
This
No,
ma'am.
is wrong.
7
No,
is
no.
7 is
referring
referring to
1.
1. Yes, 7 is referring 1. So this is not a foolproof method. For
Hmm.
some sentences, this will work. For others, it will not work. But is
So
the working clear?
it's a wrong entry.
Yeah, it is wrong. It will not always work. Now, if there is a sentence like this, that Rahul is a boy, he is 10 years old. So for this, now if I again assign numbers, this is 1, 2, 3, 4, and this is
Now
5,
he
6,
he
7.
will represent Rahul only.
Right. So now this pronoun 5 will represent, still this won't work actually. This will go for boy.
Boy.
Yeah, still this won't work. So if I can have something else in place of boy, basically if Rahul is the first pronoun, okay, I'm sorry, not first. If Rahul is the last noun for this pronoun he, before this pronoun, if Rahul is the last noun, only then it will work. It will be, okay, let me think of a sentence. It can
Rahul
be,
is clever or something.
if I write, I know Rahul, he is 10 years old. Okay. Now, 1, 2, 3, 4, 5, 6. So for this 4 pronoun, what is the closest sequence number, which is the noun? Rahul. So now this is correct.
Hmm.
Okay, but this will not always be the case. So definitely this will not work half the time. Okay. So is the code clear?
Yes, ma'am.
Ma'am.
Yes, ma'am.
This is
Yes.
basically your week 7, nothing much to discuss. Now you try solving your activity questions after this. Okay. If you have any doubts, you can ask. Okay. Any other queries you have? All right. Then just solve your activity and practice assignments.
Ma'am,
And
have you
yeah.
any session on Friday?
No, I don't. I don't have any other sessions for CT. I think Piyush sir will take on Friday.
Okay. Because Friday will be the
Friday is
deadline.
the deadline. Yes, we know. So there will be one session before that. Either Piyush sir or Nalini will take. Okay. All right. Thank you for joining.
Thank you, ma'am.
Thank you, ma'am.
Thanks.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am.